What's up, guys? Welcome to part 2 of the IO game series, and today we're going to add an input handler to read the keyboard input from our user so that we can enable movement for our character over here. So currently it's static, it cannot move. And to start things off, before we start, we're going to add one more property to our player, and I'm just going to call that speed. So this is going to be the speed or velocity at which the character will move. So let's just set it to 2 for now. So now what we're going to do is we're just going to create a separate file called input_handler.js to handle our input. And in this file, we're going to create a keys object. So let keys equal to, and in this object, we're just going to store the key input. So for most IO games, we're going to use WASD. So we're going to make them booleans. So W is false. A is also false. S false, and D also false. This is just to signify that the player is currently not moving and the user has not pressed down on any keys yet. So next what we're going to do is we are going to add an event listener. So window.add_event listener. And the first case is going to be when the player is pressing down. So key down. And then we're going to do E and use an arrow function. What's wrong with my keyboard? Equals, just like that. And in here, we're just going to handle the logic. So how the player is going to move. So the first case is if the user presses down on the W key. So if e.code is equal to key W, this is how you check if they're pressing down on W. Then what do we want to do? We want to set keys.w equal to true. And the other case is if e.code is equal to, what's the next one? Key A, WASD, we'll just do it in that order. Then keys.a is equal to true. And we're just going to do the same thing for the other keys. So I'm just going to remove this space. Just going to copy this, paste it down a few times, and I'm just going to change this to WASD. So this is S and this is D, S, and we'll change this to D, right? Okay, now the second case is when the player stops pressing on the button. So when they lift up their finger from, let's say, W or A and S or D, and that's just when we want to stop the character from moving. So we'll do, we'll add another event listener. So add event listener, and for this one, we're going to do key up. So this is when they lift up the key or lift up their finger. And same process, use an arrow function and that. And I'm just going to copy the code from here. Except this time, I'm just going to change the true values. So I'm just going to change all these to false. You can use Command or Control D depending on your operating system, just to select more of the same words. And now we're going to actually update our player's position and make it seem like it's actually moving. So we're going to store this in a function so we can run it in our main game loop, our draw function. So I'll just call it update player. Keep it simple. And in here, we're going to define two variables or create two variables. We'll call it let dx, and we're going to initialize it with 0, and let dy also equal to 0. And these are just delta x and delta y, so the change in the x position and the change in y position. So when it's not moving, it has no change in position, so that's why we set it to 0. And here, we're actually going to check if keys.w is true. Then we want to set the change in y position minus equal to 1, right? Because when they're pressing W or S, we're dealing with the vertical movement, so up and down. And obviously, we have to check the other cases as well. So keys.a. So now we're handling the change in x position. So delta x would be equal to, well, not equal to, but minus equal to 1. minus equal to 1, because now we're decrementing by 1, so it'll move left, right? Yeah, left on the canvas. And also keys.d, WAS. Actually, we'll do s next. .s. So this is vertical again, so we'll do delta y. And this time we're gonna, instead of decrementing, we're gonna increment by 1. And finally, if keys.d. So we'll do that. And this is handling the x position, so we'll increment by 1 to make it go to the right. Okay, now what we're going to do is we're going to create another variable, and this is going to be length. Let length. So here, what we're going to try to do is we're going to make the diagonal movement the same as just moving up and down. And this is called vector normalization. And the reason we have to do this is because if you hold down, for example, both W and D, you're going to move to the top right corner diagonally, right? And what happens is you're actually going to be moving faster because the length is really just the magnitude of the vectors added up and squared. So in this case, it would be the square root of 1 squared plus 1 squared, which would be square root of 2, and that's actually slightly greater than 1, but it does make a difference. So yeah, so length, so basically we calculate the length if the user decides they want to move diagonally. So the way we calculate the diagonal movement length is we're going to do math.sqrt, and in here, like I mentioned earlier, it's just going to be the square root of the squares of the vectors. So in this case, one of our vectors is the delta x, so we're going to square that, so we can just multiply it by itself, and then add it up to adding the other vector squared as well, which would be dy, so we can also multiply by that. And we don't have to worry about like brackets and all that extra stuff because this already handles the order of operations. So now that we have the length or the magnitude, we're going to check if the length is greater than 0 because we don't want it to be stationary. We want to make sure it's actually moving before we can apply this vector normalization. So we're going to check if length is greater than 0. So in here, if they're actually moving diagonally, right? What we want to do is we want to take the delta x and we're to divide by the length or the magnitude. So what this represents is if you've ever taken grade 12 calculus and vectors, this is basically a unit vector, and a unit vector is defined by the original vector divided by its magnitude. And we're going to do the same for the delta y position. So we're going to divide by equal to the length or the magnitude, whatever you want to call it. And after that, we're going to actually implement the logic for moving the character. So to do this, because our main game loop has this setup, the clear rect, and then the trans save, and then translate restore, and then request animation frame, which just draws it each frame sequentially, we can reference the player.x position and increment by our delta x. And here we're just going to multiply by our player speed, because currently we probably don't want a speed of 1. That would be very slow. So that's why we have this speed property here, which would make it slightly a bit faster. You can also change it to 3, 4, 5, whatever, however fast you want your character. And we're going to multiply by our player.speed. Same thing for our player.y position. So plus equal to dy times player.speed. Player.speed, right? And now we're just going to actually update this player position in our draw function. So before anything even happens, any updates, before we actually clear the canvas and all that, we're just going to update our player every frame. So update player, we're just going to call the function like so. And if we save that, oh, what happened? Okay. Oh, wait. Oh, I think it's oh yeah, sorry, my bad. We forgot to call our script, so that's why it's not running. So okay, let's just create a script tag. So for now we're just gonna put it before everything, because for input handling we always want it to prioritize it first, even before the map loads and all that. So we'll do script source is equal to input handler.js, what we named it. And if we save that, I think that fixes it. Oh, there we go, nice. And there you go. So now we have our character moving, right? So you can see it's a bit slow. I might change the speed for that one. So we can easily just go to main.js and you can change the speed to however you like. We can do 5. Ooh, very fast. Even 100. Oh my, holy cow. Okay, so as you can see, that's a bit too fast. But also, if you notice carefully, let's just change it to 5. What can happen is you can actually go outside of the border. And that's something we do not want. So what we can do is, if we go back to our update player position, we can actually, what we want to do is we want to make it so that we can collide with the borders, right? So instead of just implementing a direct collision detector function or whatever, we can just clamp the player position such that it never exceeds these bounds. So, okay, so underneath, when we're updating our player position, we can access our player.x position, because that's what we want to restrict or hinder. So we'll do player.x, and we will use, what do we use in this? Okay, we can use math.max. Yeah, we can use math.max. That'd be simple. So we'll use math.max, and here we just want to return essentially the farthest distance the player can go, which in this case can hold around 2 parameters, right? So we'll do player.radius, right? And this is essentially going to clamp our player's position. So player.radius, and second parameter will be math.sign. Our player.x, map width, which we created in map configs, minus player.radius, right? I like semicolons just for good coding practice. What happened here? Did I do a typo? Okay. Okay. Oh yeah, there's some typos. Also, why am I using math.sign? Should be math.min. Okay. Math.min, player.radius. Oh dear. Okay, yeah, it's a typo. Okay. So basically what this is doing is, for math.max, whatever parameters we pass in, it can take in a lot of parameters. It'll basically return the largest number amongst them. So what can happen is sometimes our character, it can go outside, right? So like we saw earlier when it went outside, if it goes negative, it'll choose the largest value. So what this part is doing here, so math.min just returns the smallest, right? What this is doing here is it just wants to take the smallest value between player x, so that's the x position of the player, and we do math width minus player.radius. So that's the map width is from here all the way up to here, and the reason why we subtract player.radius is because if we don't, what will happen is we'll just the center of mass here will be clipped into the border, and so it's technically kind of like, it'll look like it's glitching, and we don't want that. So you can see this does the job nicely. As you can see, it just sits nicely, snugly right at the border, which is good. But as you can see, we still haven't applied it to our y side, right? The y coordinates. So to do that, we can just copy this and just change it to player.y. So this time we're changing the y position of the player, and instead of player.x, we're going to do player.y. So this limits or hinders its movement from the top to the bottom. So as you can see, we cannot go beyond when x is equal to 0, and we also can't break past the border at the bottom. So this is about it for our input handler tutorial. Hope that helps, and I'll see you in the next one.